Okay, we're going to start 2.1, which is solving equations using the addition property. The whole goal when you're solving equations is to get the variable by itself and to get a number on the other side, some kind of a real number. So we want, for an example, as our goal is to get a variable by itself. An equal sign and some kind of a real number. Now what I mean by the variable by itself is we want the coefficient to be 1. For example, we should have an equation, work, and get a variable by itself. You know, when a variable is by itself, it implies the coefficient is 1 equals some kind of a real number. So that's what we're shooting for. Now, using the addition property here consists of either adding or subtracting variable terms or constants. Keep in mind a variable term is something like 5x or 3 over 4w. A constant is just a number that stands by itself, like 3, -5, or 1/4. Remember, what you do to one side of the equal sign, you do to the other side. So we're going to look at our problem. X minus 8 equals 9. The whole goal, once again, variable by itself, a real number on the other side, which we have our equal sign here. We want to get x by itself, which means we need to get rid of this constant, this -8. How do we get rid of this -8? Addition property tells us we're either going to add or subtract. Well, we're going to do the opposite. Plus 8. What you do to one side of the equal sign, you do to the other side. That will cancel out. We're only left with x equals. We sum these two, we get a solution of 17. Make sure you check your work as well. Okay, let's look at the next problem. Once again, still doing the same thing. Our equation is x plus 7 over 10 equals -1 over 5. Our goal here, once again, is to get x on one side of the equal sign. Right now, on the left side of the equal sign, we have x plus and 7 over 10. We need to get rid of this constant. We need to get rid of this positive 7/10. So we're going to do the opposite. Subtract 7 over 10. What you do to one side of the equal sign, you do to the other side of the equal sign. You see positive 7/10 minus 7/10 will cancel out. We'll be left with x by itself. Now from here, it's just working out this math over here. -1/5 minus 7/10. Well, you should now know from the previous chapter and from O300 that you can't subtract or add fractions unless you have a common denominator. So here, our common denominator for this problem will be 10, which means we'll have to multiply this by 2. We do that to the bottom, we have to do that to the top. So now we're left with -2 minus 7 over 10, which will give us -9 over 10. And we notice that this cannot be reduced any further, so we get this as our solution. Once again, make sure to check your work. Next problem, we have 4x equals 3x minus 3. Once again, what we're doing in this section is solving equations using the addition property, which means we're either going to be adding or subtracting constants or variable terms. And if we go back on the very first problem, we saw the variable term is something like a coefficient and a variable, coefficient and a variable. So we're either going to be adding or subtracting these. So if we look at this problem here, we have a variable term. We have a variable term and we have a constant. Well, our whole goal is to get, first of all, the variable on one side. We have variables on both sides. If we notice here, and we get rid of this positive 3x, bring it to this side once again by doing the opposite, positive 3x, so we subtract it. First of all, we see now variables gone from the left side, right side of the equation. We're only left with the negative 3. And a very nice problem because 4x minus 3x just gives us a solution of 1. So here, what we did this time, instead of moving the constants, we moved the variable term, this 3x, by subtracting it, and we saw that it gave us just our coefficient to be 1, so therefore we are done. Once again, make sure you check your work. Another problem here, pretty similar to the previous one. The only difference here is that our variable terms are fractions instead of whole numbers. Once again, our whole goal is to get the variable on one side. I got r on the left side, r on the right side. I just want it on one side. One tip that you should know here is that you should always be moving the smaller variable term. So let's note that, okay? Always move the smaller variable term. Well, you might be asking yourself, did we do this in the previous question? Well, let's look back. Variable term was 4x, other variable term was 3x, and we moved the smaller one. 3 is smaller than 4, so we moved that one. So let's do the same thing here. We want to move the smaller variable term. Well, we have 7/4 r and 3/4 r. The smaller one of these is going to be the 3/4 r. They both have similar denominators. We see this is an improper fraction, which will give us a whole number. Proper fraction will not. Another way to figure out which one's bigger is just by dividing them and look at the fraction as a decimal, and the smaller decimal will be the smaller one. So we're always going to move the smaller variable term. So we move this 3/4 r, which is a positive, by subtracting it. Well, what happens? This cancels. It cancels, and keep in mind, it doesn't just turn into nothing, but it actually turns into 0. We want to make sure we keep our equation. Bring everything down. Well, here we get what? 7 minus 3 over 4r. This problem's nice because they have the similar denominators. Well, 7 minus 3 is 4 over 4r minus 1. And let's reduce this, which just turns into 1, or we don't even have to show it anymore. R minus 1 equals 0. Very nice. We get r by itself by adding 1 to both sides. R equals 1. Once again, make sure you check your work. And now let's go to the last problem that we'll be looking at in this section here. I like to do this problem because we have a lot of fractions, and one thing that fractions do is kind of scare people, but problem not too bad. Let's just keep in mind what we've been doing in the previous problems here. It looks kind of lengthy right now. Let's see if we could combine some like terms. What do we see here? We see that on this right hand side we can combine those two. Alright, so let's rewrite everything else. Let's try to simplify if we can before we start using our addition property. 4/9 plus 4/9, well, denominators are the same. We add the numerators. We get 8 over 9 minus 1 over 7x. And now you see you have a variable term here and a variable term there. Once again, keep in mind, let's move the smaller variable term. Well, which one of these is smaller? We have a positive 67x, negative 17x. Well, you should know that a negative number is smaller than a bigger one. So we're going to move this negative number. Once again, we're just using the addition property. So this is a negative 17x. So we're going to do the opposite, and we are going to add. Once again, what you do to one side of the equal sign, you do to the other side. Make sure you match it up with the other variable term on the other side. Those will cancel out. 6 over 7x plus 1 over 7x gives us 7 over 7x, which reduces to just x, because 7 over 7 just equals 1. So we're left with plus 1 over 4 equals 8 over 9. So problem becoming very nice now. Now our variable is by itself. The coefficient is 1 because 6 over 7 plus 1 over 7 just gives us 1. And we really don't have to show that. Now we just want to get variable by itself. We have two constants. Well, let's get rid of this constant by doing the opposite, subtracting. That cancels out. We're left with x equals. Well, now what we need to do is, in order to subtract these, we need to find our LCD, which is going to be 36, which means we're going to have to multiply this by 4, multiply this one by 9. We'll get 32 minus 9 over 36. And then we're just going to subtract the numerator part, and we'll get x to equal 23 over 36. We see that this will not reduce any further. That's our solution. Once again, make sure you check your work. And this concludes 2.1.